everyone, thanks for coming. My name's Keegan. I'm a Director of Solutions Engineering at Intel, more particularly within Intel Software Division, which we call Intel Tiber. Really thankful you all came for a lightning talk here today, where I want to speak about some of the biggest challenges that we see across our customer base, particularly with Databricks, as well as what are some of the solutions that we see in the market for addressing those modern challenges that we see as big data becomes more and more integral into every company's technology stack. More specifically, here are the four main things I want to focus on today. Here are the four main challenges that we see across the industry. Complexity, visibility, scalability, and dynamic nature of workloads. Starting off here with complex data workloads, there's many different ways that we see complexity is rising in the market. We can think of complexity of the scheduling of jobs, such as externally scheduling with solutions like Airflow or ADF. We can think of the types of data that we're working with, of different data types from different sources and different integrations. We can also think about the volume of jobs and the volume of clusters that we're needing to run, scaling from 10 to 100 to thousands of clusters and managing them all both for performance and cost, not to mention end user impact. The second biggest challenge that we see here is visibility, and this really scales linearly with the complexity that we see. As we are growing in the amount of clusters, how do we continuously get that observability and visibility that we need for the performance of our clusters, such as job completion time and performance metrics, but also in cost. As we see visibility becomes more and more difficult across big data platforms, it can make it really difficult to understand the insights you need to iterate off of these clusters, particularly with cost, which is why we are seeing continuously across major big data players that costs are rising quickly. The third aspect here, scalability. How do we manage these hundreds or thousands of clusters to make sure we have the proper SLOs and the proper costs? We see autoscaling today playing a big part in that today, whether you may or may not be doing it. And then the fourth aspect here is dynamic nature of workloads. We can think of this from perspective of batch workloads, where input size is dynamically changing. We can think of it in streaming clusters that need to continuously adapt to new requirements or new sizing. And the four of these together are acting as really major challenges across organizations that we're seeing. I want to take today to focus on 1, 3, and 4. Regarding big data visibility, there are absolutely some really great solutions out there. Unity Catalog is one, for example, that some of you may be using. But I want to talk about how there are possible solutions to address 1, 3, and 4. Two main solutions that we see regarding improving the performance of Databricks environments to address those 3 points are Photon and Project Luton. I'm sure most of you by now are familiar with Photon. It's the engine powered by Databricks to improve the performance of your clusters, which should in turn improve your SLOs, such as job completion time, and in many cases also improve the cost efficiency of your clusters. However, a major challenge we see, particularly with Photon, is it is meaningfully more expensive. So we, of course, need to validate that when we are adding Photon, that we are getting the ROI needed when adding that additional cost. And the second aspect here is Project Luton. Project Luton, in a way, is a little similar to Photon, an open source software that Intel itself helps contribute to. And we have many different ways that we help here improve performance with Luton, such as plan conversion, fallback processing, and memory management, to name a few. All with the idea, between Photon and Luton to improve performance. Now, I only list these two here as we speak to more and more customers, they are struggling aside from these two aspects about how do we improve performance more. When we see more and more organizations moving away from these data centers and self-hosted Spark environments, the amount of control that they have on a per cluster basis can become more difficult to perform these performance optimizations themselves, not to mention when we think about the complexity of scale, how do we improve performance for hundreds or thousands of clusters at a time, given how there's only a set number of engineering hours that they have to work with. And it's those main challenges that has inspired us at Intel to develop what we call app level optimization for Databricks. where we have come with our solution to act as a unique player to improve performance and improve the cost of Databricks workloads at scale in a very quick time period. More particularly, we go about it in a different way than we see other vendors or software platforms doing so, in which we apply performance optimizations and orchestrational optimizations to reduce the cost of Databricks workloads on average by about 25 to 30%. How exactly do we do that? First here is with runtime optimization. This is a really unique aspect that we go about to improve performance. With our agent solution, we actually optimize the JVM itself. And we optimize mechanisms like thread pool management, garbage collect, the JIT compiler, and I'll give more details on that momentarily. But we do so to improve CPU utilization and improve job completion time. We also paired those runtime improvements with what we call dynamic capacity management and seamless scaling. When we look at all of these different managed cloud platforms, you could think of Databricks, EMR, Dataproc, bundling them all together. We see auto-scaling is becoming more and more adopted across organizations. However, it still leaves a very big gap between the amount of resources that they're provisioning versus what they're actually utilizing. That has enhanced us to come out and develop our own more optimized version to assist with the scaling to make sure at any given point in time for hundreds or thousands of clusters, you're only provisioning what you actually need. So how exactly does all of this work? I'll start off here speaking a little bit more regarding the runtime optimizations. Here's some of the kind of things that we're doing, again, majorly at that Java or JVM level. The way we go about this, again, we're an agent-based solution. So let's say you have a workspace that you're interested in optimizing. You deploy your agent, and it would begin profiling to see what optimizations are applicable, whether it be crypto and compression acceleration, memory arenas optimization, amongst a few others. A very common one is regarding JVM runtime optimization to implement inlining. It's very common that we're profiling these ETL pipelines where we see you have one function calling upon another function within a particular job that has a very repetitive and predictable response. Our agent, on a per job basis, can implement inlining to cache the results of this response, shortening the size of your call stack and shortening the length of the ETL. Doing this for 1, 2, 3 jobs is difficult. Doing this for hundreds or thousands of jobs can become impossible, which is why we developed this agent solution to do it automatically for you. We paired those runtime improvements with the orchestrational optimizations, and here is a good visual of what I mean by optimizing the gap between requested and utilized resources. If we look here on the left, here is how we see the default Databricks autoscaler working without our solution here at Intel. More particularly, we have this red line and blue line representing at a given point in time the amount of instances that are provisioned versus the utilization. And you can think of utilization as CPU or memory or network utilization. And there's a gap between the two. And that is the area where we see that there's over-provisioning and room for cost improvement. What we do, and we can see that here on the right with this yellow line, is we have developed a more enhanced version of the autoscaler where we are continuously scanning your SLOs, such as job completion time, as well as utilization metrics, such as input size, CPU utilization, and memory, so that at any given point in time, you are provisioning the amount of resources you actually need. And you can see there's still a little bit of a gap between the yellow and blue line in case there is sudden, dynamic, unpredictable behaviors that may occur. However, the size of the gap between the blue and the red becomes drastically shorter. And those are the two approaches that we take that are complementary on top of Photon as well as Glue to improve performance by 20 to 30%, as well as cost for 20 to 30%. So what does the process look like? It requires 0 code changes if you wish to move forward with our solution. It's really just 3 steps of install, evaluate, and activate. The first step here with install, we install via workspace init script. So all you need to do is decide which workspaces that you wish to optimize, implement the workspace init script within the Databricks UI, and have that init script point towards the appropriate workspaces. After you have installed our agent, we go in this evaluate stage or learning period. Again, we have those two optimizations, the runtime and the orchestration. So after we are deployed for a period of about 5 to 7 days, we are only learning, we are not optimizing, to understand what optimizations are applicable for both categories. And then after that 7-day period, you can activate either via a UI button or an API call, where our agent will load those optimizations for you on your behalf, and you can immediately feel those performance benefits and cost benefits. And here's a real-world example of what that looks like. So we have partnered with American Airlines to optimize their entire Databricks fleet, where we saw an average cost reduction of about 23% across hundreds of clusters. When we first started working with them, they've done all of the, we'll call it obvious things. They've explored Photon, they've explored Glue. They also worked really hard on data visibility or observability to reduce their costs. Unity Catalog is a really good example of that. However, it's very common that we see when folks adopt these solutions, they become stuck, where there's no longer opportunities to reduce costs by 20% or 30%, but rather they're investing significant efforts to reduce it by 5%, while the complexity of their environment grows. That is what inspired them to work with us, after which we optimized their first workspace within a period of about 2 weeks. After they saw the immediate results there, they deployed us everywhere. And it was a very quick process where within 4 weeks, we have optimized their entire fleet. I also want to call out here, what we're particularly looking at with this graph on the right is an overlay comparison of their ETL behavior before and after activating Granulate. The dotted blue line is representing before, or what we call as the passive state without optimizations. The orange line is representing the active state. And this is a good visual of the performance optimization and the cost optimization with the orchestrational improvements coming in, where we can see not only is the length of the ETL shorter, but at a given point in time, the amount of instances that we are provisioning is less, allowing them to enjoy job completion time improvements and cost improvement. It's also important to note, by the way, these improvements can be felt on your DBU spend as well as your infrastructure spend, whether on AWS, GCP, Azure, or any other cloud. Now, what I presented here today is really only one aspect of what we do at Intel Tiber. At app level optimization, we focus on reducing cloud spend. That's why we're talking here today about improving performance and reducing costs for Databricks. However, we do have a few different products here that can help depending on what you're looking at. If you wish to simplify your AI pipelines, we do have something there with Developer Cloud and AI Studio. If you're looking to improve the security of your cloud or data center, we also do have trust services. And then if you're looking to scale your edge services, we also do have our edge platform. The main goal is to have one product suite here with Intel Tiber, where we can do all of things together as a one-stop shop. I'm about 6 minutes ahead of schedule here, but that is the majority of what I wanted to go through here today. I will stay after to see if there are any questions. Otherwise, I really appreciate you all coming.